Hello and welcome you all. I, Professor Vipin Chopade, working at AISSMS Institute of Information Technology, Pune, at Department of Engineering Sciences. In this video, I am going to talk about a manufacturing process, particularly about a casting process. Let's talk about sand casting first and its learning objectives. So by the end of this session, student must be familiar with the concept of casting, its uses, the concept of pattern, the core making, mold making, and stages involved in sand casting, advantages and disadvantages of sand casting process. Let's talk about casting first. Casting is nothing but when you pour a molten metal into a mold cavity, then you have to solidify it for some time. Then after solidification, you have to take out that part outside that of the cavity. Then the output part is called as casting. So let's talk about mold. A mold is formed into a geometric shape of the desired part. Particularly, a mold is a box combination of cope and drag box. And in that box, we have to pour a molten metal in cavity. And after solidification, we have to break that mold and take out the solidified part. That solidified part is called as casting. What are the generalized terms that are used in casting are pattern, core, mold, and casting. Let's talk about pattern making first. What is pattern? It is the exact replica of the casting that we need to be manufacture or produce. What are the materials that that are used to manufacture the patterns are wood, plastic, or metals, sometimes aluminum and steel. Then types of the patterns are solid pattern, match plate pattern, cope and drag patterns. And what are the characteristic or design parameters of this pattern depends on. This design parameters of this pattern depends on shape and complexities of the casting, then type of the molding adapted, then number of the casting to be produced. So these are the things on which the design of the pattern depends. So what we can say, a poor pattern results in a poor casting and a good pattern results in a good casting. That's why a pattern making is a very important step in your sand casting process. Second is your cope and drag pattern. What is cope and drag? A mold box consists of two halves. The upper one is called as cope box, the lower one is called as drag box. And the cavity consists of a cope pattern cavity and a drag pattern cavity separated by a parting line. See, this is the figure which shows a symmetric pattern. The lower one is called as drag, the upper one is called as cope, and they are going to be separated by this parting line. This is a runner portion and this one is your plate on which this drag pattern and cope patterns are placed. So cope and drag pattern is a two-piece pattern representing the casting and divided at the parting line. Yes, it is a symmetric pattern. The lower one is called as drag, the upper one is called as cope, and they are separated by a parting line. Each of these two holes are mounted on the plate for easy alignment of the pattern and mold. Yes, they are mounted on a plate for easy alignment and pattern of the mold, right? The cope and drag pattern enables the cope section of the mold and drag section of the mold to be created separately and later assembled. Means we have to place this part in one box and this part in another box, and we are going to attach the both boxes, and that attach whole assembly is called as mold box. So mold box consists of drag box consisting of drag pattern and a cope box consisting of cope pattern. Let's talk about sand casting. What is the sand? It is a molding sand. It is widely used casting process in the manufacturing. Almost all metals can be sand cast. Almost every metal can be casted. Simple, complex and large castings are manufactured. Silica sand, it is the material which is used as bonding agent. What is the mixture consisting of this molding sand? It is a 90% of the sand, 6% of the clay and 4% of the water. So this is the mixture which consists of molding sand. It is inexpensive and very resistant to the elevated temperature. And what are the application areas of this sand casting? These are engine blocks, machine tool base, cylinder heads, and pump housing and valves, etc. These are the application areas. Then stages involved in the sand casting. So first stage is you have to place the drag pattern on your board. Then this drag pattern is placed on the board. After placing of the drag pattern, you have to sprinkle the molding sand around that drag pattern to fill this box uniformly. Then you have to ram that molding sand properly in order to achieve a uniform distribution of the molten metal around the drag box. Then after ramming, excessive sand is leveled off and using vent and vent holes. These are made in the drag to facilitate the removal of the gases during pouring. We have to produce a vent hole in order to liberate the gases during pouring. Then finished drag flask is rolled over the bottom board exposing the pattern. So this get reversed in direction. Then this lower box is ready. This is your drag box. Similarly, the upper box, which is cope box, is produced in the same manner. See here, a cope pattern is placed on the board. Then after placing of the cope pattern, molding sand is sprinkled. Then that molding sand get properly rammed. And after ramming, vent holes are produced. A place for sprue and getting system are generated. Runners and risers are generated. And this cope box manufacturing takes place. Then stages involved in the sand casting. So what is the first step? The sprue and riser pins are removed. So sprue and riser pin first we remove from the drag and cope box. Then patterns fill the cavity using this sprue and runner. So here molten metal is poured in a getting system and the hollow casting get filled up. And final finished product are obtained outside. So this is called as solidified casting. So this is the complete flow of the casting process. Then next one is core making. The core is nothing but a formation of the hollow casting. Consider this one is your casting component and you have to keep this casting hollow at this point. So you have to keep something product in that casting which left there even after pouring of the molten metal. So this part will resist the molten metal to flow at this place, leaving behind a hole or hollow cavity at this place. So in order to manufacture a hollow cavity, you have to design a product which is placed in a cavity, so which prevent the flow of the molten metal to enter into the cavity, hence a hollow casting generated. So this is a core manufacturing. What are the advantages of the casting process? The advantages, any complex part can be casted first. The second one is heavy components can be casted. Then the third one is accuracy is bit good. Then weight saving components can be manufactured using castings at reasonably low cost. Then the structure of the casting is fibrous, low grain size and low cost. You can achieve control over its grain size. So these are the advantages of the casting process. What are the disadvantages? It is only suitable for mass production. It is not suitable for job production. Then poor dimensional accuracy is achieved. Why? Because you are pouring the molten metal into the cavity and that molten metal get cooled, and by the cooling process the gases are liberated which generates pores, hence the casting becomes brittle. So these are the some limitations. I hope you are now familiar with the casting process, the gating system, and stages involved in the casting process. Yes, thank you. Thank you.